In 2021, the British biotech company Oxitec, owned by a U.S. firm, released 144,000 mosquitoes in April by placing boxes with insect eggs at 6 different locations. Once they hatched, approximately 12,000 males were expected to emerge weekly for 12 weeks, totaling 144,000 mosquitoes. By 2023, the number of mosquitoes released had risen to 3 million. Here's how it worked. An Oxitec box was placed on a volunteer's private property, water was added, and that was it. No further intervention was needed. The final phase of mosquito release concluded in November 2023. But there's one critical point. These mosquitoes were genetically modified. It might sound like the start of a zombie apocalypse, but can mosquitoes really be that dangerous? Why were they released? And what's going on? We'll dive into that soon, but first a quick break. Here's a subtle reminder to hit the like button if you forget later on. Let's get started. The first question I had when I heard about the release of genetically modified mosquitoes was, how did people react to such a project? People usually fear GMOs, and sure enough, they didn't disappoint.
We are humans and we don't like being treated like guinea pigs.
We humans don't like being treated as guinea pigs. From the moment the project was first announced in 2011, it faced resistance from local communities. The concerns raised weren't just empty complaints. As rumors about mutant mosquitoes spread, public response was swift. Over 100,000 people signed a petition on Change.org opposing the initiative. By 2016, that number had grown to over 160,000, and by the time this video was made, nearly 238,000 people had signed. I may have rushed to judgment, but I'm still not sure if the petition had any real impact. Since 2011, media reports have quoted angry residents who refuse to be guinea pigs for the superbug or Frankenstein mosquito. Entire campaigns were launched to stop the trials until more research could be done. In short, people's outrage can be summarized in one phrase. You can't experiment on people without their consent. Once mosquitoes are released, there's no way to take them back. It's hard to argue with that. Nevertheless, despite all the protests, federal regulators gave the project the green light, so the petition didn't really change much after all. Now it's the right time to understand which mosquitoes we're dealing with, because they don't just release any type. We're talking about the Aedes aegypti mosquito, also known as the yellow fever mosquito. In recent years, this species has become an increasing global threat. These mosquitoes inhabit areas near roughly half of the world's population, and they are spreading rapidly. After decades of effort, there is still no cure or specific treatment for many of the diseases transmitted by these insects, including dengue fever, Zika virus, yellow fever, and more. The yellow fever mosquito, Aedes aegypti, is an invasive species, and if you've seen a few of our previous videos, you'll know what that means: rapid spread, fast reproduction, and territorial takeover. Currently, this species is found in tropical, subtropical, and temperate regions worldwide. Of course, people are fighting back against yellow fever mosquitoes with traditional methods, primarily by spraying various chemical insecticides. However, while these methods can be effective against other insects, insecticides have not been successful in curbing the spread of mosquito-borne diseases. Every year, between 100 and 400 million people suffer from dengue fever, a debilitating and sometimes fatal illness. In short, the mosquitoes being released in the US are incredibly dangerous. And to make matters worse, they are genetically modified. But how exactly are they modified, and what do we know about the company behind this? Oxitec, the company responsible, was founded in 2002 by professors from Oxford University, but is now owned by the global biotech giant Trexon. Whether that's a positive or negative thing is up to you, but they are indeed creating genetically modified mosquitoes, and here's how it works. It all starts with mosquito eggs, which are laid by female mosquitoes in a special facility known as the egg production colony. Each large cage houses about 12,000 female mosquitoes. When the females lay their eggs, scientists collect them for research. The eggs are incredibly small, roughly the size of a grain of fine salt, and are lined up in rows. The most intricate part of the process involves using microscopic needles to inject a tiny drop of patented synthetic DNA into each egg. This procedure is extremely delicate and requires a high level of precision. After the injection, Oxitec technicians monitor the eggs for 4 days, observing as the larvae hatch. At this point, the female mosquitoes are separated from the males by hand, which may seem impossible when dealing with such tiny, wriggling creatures. However, scientists distinguish them by size. Females are always larger than males, a common example of sexual dimorphism in the insect world. The larvae that survive the injection are then put through a series of tests to ensure the genetic modification was successful. The result of this process is the creation of OX5034 mosquitoes, a genetically modified version of Aedes aegypti. These mosquitoes are engineered with a self-limiting gene. This gene prevents female mosquitoes from surviving to maturity, meaning only males which do not bite are left. That's the basic concept. Only genetically engineered male mosquitoes survive and are released. Oxitec placed modified mosquito eggs on private properties throughout the Florida Keys in 2021. The adult genetically modified mosquitoes are almost identical to their wild counterparts, making them indistinguishable to the naked eye. Wild mosquitoes, unaware of the genetic alteration, mated with the modified mosquitoes, spreading the self-limiting gene throughout the population. The gene ensures that only male offspring survive, leading to a potential long-term suppression of the mosquito population over multiple generations. In essence, these genetically modified mosquitoes are similar to sterile insects, a technique often used in pest control. Normally, sterilized insects are created by exposing males to gamma radiation before releasing them into the wild. In the case of Oxitec mosquitoes, the self-limiting gene is synthesized from E. coli and herpes simplex virus. This gene is lethal because it produces a protein called TTAV, which disrupts cellular activity, killing the mosquitoes before they reach adulthood. I see where the confusion comes from. Let me break it down more clearly. The genetically modified mosquitoes carry a lethal gene that causes them to die in the larval stage unless they receive an antidote, specifically tetracycline. In the lab, the scientists provide this antidote to the mosquitoes during their development, allowing them to survive to adulthood. Once they become adults, they can mate with wild female mosquitoes, passing on the lethal gene to their offspring. In the wild, however, the mosquitoes don't have access to tetracycline, meaning their offspring will inherit the lethal gene and die before they reach adulthood. This self-limiting approach ensures that after a few generations, the mosquito population starts to decline because the females, who are the ones that bite and spread diseases, don't survive, while only males who don't bite are left to reproduce. Additionally, researchers introduced another synthetic gene from coral DNA into the mosquitoes, which makes them glow red under certain lighting conditions. This helps researchers track the modified mosquitoes in the wild and monitor the success of the project. So, why release genetically modified mosquitoes? Traditional methods like spraying insecticides or using larvicides haven't been very effective in controlling diseases like dengue fever and Zika, especially when mosquitoes can develop resistance to chemicals. The Aedes aegypti mosquito, which only makes up 4% of the mosquito population in Florida, is responsible for 100% of the mosquito-borne diseases in the area. The genetic modification approach aims to control the mosquito population in a way that specifically targets this species without wiping them out entirely. The goal of Oxitec's experiment is to reduce the number of mosquitoes capable of spreading deadly diseases. In their trials, male mosquitoes with the lethal gene successfully mated with wild females, passing on the gene to their offspring. Scientists collected and analyzed over 22,000 eggs, discovering that only males survived to adulthood, confirming the effectiveness of the genetic modification. However, the lethal gene persists for only 2 to 3 months, meaning its effects are temporary and the gene doesn't remain in the environment long term. This helps avoid completely eradicating the Aedes aegypti species. As for why this testing was done in Astros, Florida, it's because the region has faced outbreaks of diseases like dengue fever and asterisk Zika virus, both of which are transmitted by asterisk Aedes aegypti mosquitoes. In 2009 and 2010, local authorities struggled to control the mosquito population with traditional methods like spraying insecticides from planes, trucks, and even backpacks. They even tried introducing fish that eat mosquito larvae, but these methods didn't work and the mosquito population continued to spread diseases. Florida spends over $1 million each year on mosquito control, but much of that money is wasted because traditional methods haven't proven effective. As a result, people in the Florida Keys have grown accustomed to insecticides being sprayed from the air, and using mosquito repellents and mesh screens has become a way of life. A recent survey showed that 78% of people in the U.S. would support the use of genetically modified mosquitoes if it meant containing the spread of dangerous diseases like dengue and Zika. In summary, genetically modifying mosquitoes is currently one of the most effective ways to tackle diseases spread by Aedes aegypti mosquitoes, especially since other methods have largely failed to control their population. The situation with genetically modified mosquitoes, while promising, is not without its complexities. There's even a study suggesting that the outcome of releasing these mosquitoes may not be as straightforward as anticipated. However, some of the study's phrasing might be misleading, and even the editors of the scientific journal in which it was published have acknowledged concerns about the possibility of random hybrids. Oxitec, the company behind the genetically modified mosquitoes, maintains that the DNA of these mosquitoes will disappear from nature within 10 generations. This is largely because mosquitoes with the introduced genes can't produce viable female offspring, and they're also more susceptible to chemical insecticides, which further limits their survival. But there's another potential risk. The antidote for the lethal gene, tetracycline, is an antibiotic commonly used on farms, both in livestock and crops. If mosquitoes were released near such farms, there's a chance their offspring could come into contact with tetracycline, survive, and potentially lead to an increase in genetically modified mosquitoes, ones that could be even more dangerous. Therefore, releasing these mosquitoes near agricultural areas isn't a viable option. Despite these concerns, Oxitec is planning to release genetically modified mosquitoes at a test site in Asterisk, California. The U.S. Environmental Protection Agency, EPA, has already approved pilot programs for Florida, Texas, and California. However, due to bureaucratic delays in California, the company's focus has remained on Florida for now. Opposition exists in California, primarily because Aedes aegypti mosquitoes have not been a significant vector for disease in the state. As a result, some critics argue that the potential benefits of these genetic modification programs are limited. However, the company chose California for a reason. Dangerous mosquitoes were first detected there about 10 years ago, and their numbers have grown significantly since then. The U.S. is not the only place where Oxitec has conducted these trials. The company has released over 1 billion genetically modified mosquitoes in various countries, including Brazil, Panama, the Cayman Islands, and Malaysia, as part of efforts to combat diseases like dengue fever. For example, in the Cayman Islands in 2010, a relatively small release of genetically modified mosquitoes resulted in an 80% reduction in the population of disease-carrying mosquitoes. Beyond dengue, Oxitec is also targeting mosquitoes that spread malaria, focusing on species like Anopheles stephensi in India and Anopheles albuminus in Central and South America. These species are resistant to insecticides and often bite people outdoors, which makes traditional methods like mosquito nets less effective. In regions like Central America, where 50 million people live in malaria risk zones, or East Africa, where malaria is a critical health issue, genetically modified mosquitoes could offer a much-needed solution. In summary, while genetically modified mosquitoes have shown great promise in reducing populations of disease-carrying insects, the approach is not without risks and concerns. The main challenge lies in balancing the benefits of reducing disease transmission with potential unintended consequences, such as the risk of survival of genetically modified offspring due to environmental factors like antibiotic exposure on farms. However, these programs are seen as a last resort in the fight against mosquito-borne diseases, given the failure of traditional methods like insecticides. Yes, you're absolutely right. Humanity has been waging a relentless war against mosquitoes for centuries, constantly developing new methods to fight them as old ones become less effective. It makes sense that someone at some point would have thought about wiping mosquitoes off the face of the planet entirely, especially considering the staggering death toll they've caused, particularly through the spread of malaria. Mosquitoes have likely killed half of the human population over the past 50,000 years. But like you said, there are a few significant buts to this idea. First, it's important to remember that of the approximately 500 mosquito species, only about star 100 star of them bite humans and spread diseases like malaria, dengue, and Zika. This raises the question, do we really need to eradicate all mosquitoes, or should we just target the species that are harmful? In fact, many scientists have considered the possibility of eliminating disease-carrying mosquitoes. But the problem is we don't fully understand the ecological consequences of doing so. Mosquitoes, as annoying and dangerous as they are, play a role in various ecosystems. They're a vital food source for many animals. Asterisk bats, birds, frogs, fish, and even dragonflies, which are sometimes called mosquito hawks because they can consume up to 100 mosquitoes a day. While it's true that no animal is entirely dependent on mosquitoes for survival, their abundance makes them an easy food source. If mosquitoes were suddenly eradicated, it would certainly force many animals to adapt their diets. And this could cause some disruption, at least in the short term, that it's a bit like imagining if all the rice in the world disappeared. People don't survive on rice alone, but it's a staple for millions, so its sudden absence would cause widespread hunger and possibly even death. In the same way, eliminating mosquitoes could create an ecological gap that could lead to unintended consequences, possibly endangering some species, disrupting food webs, or even leading to new problems that there's also a risk in creating a vacuum in eye-off, blood-sucking insect niche. Evolution doesn't tolerate empty spaces for long, and it's possible that another, perhaps worse, insect could take the mosquito's place. That new species might be harder to control, bite more aggressively, or spread even more dangerous diseases. Nature tends to fill empty niches quickly, and the replacement might make us nostalgic for mosquitoes. Crazy as that sounds, this unpredictability is what makes total mosquito eradication seem unwise or even reckless. Historically, whenever humans have made significant alterations to ecosystems, like wiping out species, the consequences have rarely been positive. There are often cascading effects that we can't foresee. That's why scientists hesitate when asked about the feasibility of eradicating mosquitoes. It's not just about killing mosquitoes, but understanding how their absence would ripple through the ecosystem. Genetic modification, on the other hand, seems to offer a more targeted and potentially safer solution. Instead of wiping out mosquitoes entirely, scientists can modify certain species to reduce their ability to spread disease without erasing them from the ecosystem. As we've seen in places like Brazil, where GM mosquitoes have already been released, these efforts have shown promising results. By releasing genetically modified mosquitoes that carry self-limiting genes, it's possible to drastically reduce populations of dangerous species like Aedes aegypti without causing the complete extinction of mosquitoes, and thereby minimizing ecological risks. In conclusion, while total eradication of mosquitoes might sound appealing at first, the potential ecological impacts and unknown consequences make it a risky idea. Genetic modification appears to be a more refined and sustainable way to protect human health without causing long-term harm to the environment. It's fascinating to see how technology and innovation are being leveraged to combat the ever-growing problem of mosquito-borne diseases, particularly in Brazil and globally. The case of Congonhas, Brazil, is a real success story and highlights just how effective these innovative methods can be. Since July 2023, over 500 devices have been placed across 500 locations in the city. These devices contain the eggs of genetically modified Aedes aegypti mosquitoes, and within 10 to 14 days, male mosquitoes emerge and start seeking out wild females. By May 2024, only 10 months after the project began, the Ministry of Health found no breeding sites in *1004 inspected locations, an unprecedented outcome in the region. This success helped curb the mosquito population responsible for spreading dengue fever. Now, what's even more striking is how the city's dengue fever cases remained much lower compared to neighboring areas. While other cities in the region saw a 7,000% spike in dengue cases, Congonhas had a relatively modest increase of *299%. While that's still an increase, it's a staggering achievement given the circumstances. These results illustrate how these genetically modified mosquito projects, which began nationwide in Brazil in 2022, have expanded across the country and yielded promising results. Beyond Brazil, the fight against mosquito-borne diseases continues with innovative strategies like the use of Asterisk drones. In August 2024, drones were deployed over Fiji to distribute mosquitoes infected with Wolbachia bacteria. This bacteria, which occurs naturally in many mosquito species, prevents mosquitoes from carrying viruses like dengue. By infecting the mosquitoes, they can't transmit dengue to humans, offering a fascinating, eco-friendly approach to reducing disease spread. A similar release of infected mosquitoes in Asterisk Yogyakarta, Indonesia, in 2017 led to a 77% drop in dengue cases, a powerful example of how scaling up these strategies can make a huge difference in public health. The World Mosquito Program's use of drones is just one example of how new technology is helping to scale up these solutions, automating the release of infected mosquitoes across large areas. This has the potential to revolutionize mosquito control on a global level, but there's also exciting research going into using microbes from human skin to repel mosquitoes. Two common bacteria found on human skin, Staphylococcus epidermidis and Asterisk Corynebacterium amiculatum, produce a type of lactic acid that acts like a natural mosquito repellent, much like catnip repels cats. Scientists have even engineered these bacteria to reduce the production of lactic acid, creating a long-lasting repellent that could be revolutionary. In tests, this genetically modified bacteria repelled mosquitoes for up to 11 days, far longer than most commercial repellents. That if these advances continue to succeed, they could dramatically change how we deal with mosquitoes. Not only would we have better control over mosquito populations through methods like genetic modification and bacteria infection, but we might also have access to skin-based repellents that could protect us from bites long-term. This could be the turning point in the battle against mosquitoes, potentially dethroning them as the deadliest creatures on Earth. Wow, that's a really unexpected twist. It's amazing to learn that Victoria's Secret Bombshell perfume could double as a mosquito repellent for over 2 hours. It's definitely not what you'd expect from a perfume with floral notes of passion fruit, peony, and vanilla, especially since floral scents are typically known to attract mosquitoes. The idea that it might work by masking the human scent is an interesting hypothesis. It seems that mosquitoes, which usually hone in on carbon dioxide and skin odors, are thrown off by the perfume, leading them to think there's no food source around. This finding also opens up possibilities for future research into alternative methods of mosquito repellent. While DEET is the gold standard and widely used, people are constantly looking for more pleasant-smelling, skin-friendly options. The key takeaway here is that perfumes, especially in high concentrations, might offer a surprising and effective alternative to traditional repellents. But as the research suggests, just dousing yourself in fragrance probably won't have the same effect. And that story from Sri Lanka is a brilliant example of creative thinking in action. Turning newspapers into mosquito repellents using citronella-infused ink is not only clever, but also super effective, especially considering it was timed for peak mosquito activity periods in the morning and evening. The Sri Lankan Mabama newspaper's campaign to fight dengue fever with this innovative idea really caught people's attention. Literally selling out by 10 a.m. and boosting sales by 30%, but it's unfortunate the campaign was a one-time thing though, since infusing ink with citronella isn't exactly cheap. But this shows how even traditional media can play a role in public health campaigns, combining awareness with a practical solution to a common problem. Both stories really emphasize the power of innovation in unexpected places, whether it's rethinking a perfume's potential or turning a daily newspaper into a mosquito deterrent. Definitely worthy of a like for creativity.